Hello, everyone. Welcome to our presentation here on Cosmos DB Conf. We're doing a presentation today on how to use cloud-native apps with Cosmos DB and being ready for recovery. So what do we need to worry about when planning our application to be recoverable? So I am André Hax. I'm a senior director at Avanade Brazil. I work with our enterprise technical architecture team. I have a lot of experience with building solutions for our customers. I also have a lot of certifications there, including the Azure Architect one. And with me today is Jan, who's also an architect here at Avanade.
Hello, everyone. As André mentioned it, I work with him here at Avanade Brazil. I'm also an software architect here, and I have some certifications too on Azure as the solution architect. And we will present to you today some points that we need to highlight when we are working with cloud native applications and how Cosmos DB will help us on it. Okay, so I'll give an introduction here about the main point that we need to to focus here, that is the global distribution. Okay, so with the global distribution we have some key benefits of adopting it. So one of the main benefits is that we have an unlimited elastic write and read scalability on 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 our storage accounts, right? When we activate the global distribution, the region write availability around the world with an SLA of 99.99%, right? So we have a lot of availability that with our Cosmos DB account here, depending on how we configure it. So this is one of the points that we'll talk later on the presentation. Okay. The other point here that is very good on we are working with Cosmos DB is that Cosmos DB grant for us to the region write operations here in less than 10 milliseconds, right? So this is very good when we are talking about global distribution. Other point that uh, is a very good point here is about the when you need to add new regions on our storage account, we can do this without taking off our applications. So we just create add a new region on our Cosmos DB account, and as magic we are working with another region there without stopping our applications. Okay, so other point is that with Cosmos DB we can ensure our business continuity when we have an regional outage. Okay. Other points, we can scale the region right operations, the throughput of our region right operations here globally across these regions, and also we with all those points we can build high available and responsible apps, right? So the the first point that we need to talk here is how we can activate this global replication and failover. It's just like magic. We just add the regions here, the new regions that we need to geo-replicate our Cosmos DB, and our Cosmos DB started replicating our data through these regions. Okay, so the important part here is when we are provisioning our Cosmos DB account, we need to enable the geo redundancies and global multi-region rights and availability zones if we will use it. Okay, we need to enable these things on the storage account provisioning. We are not able to add this later, so we need to plan what we will do on our storage on our Cosmos DB account before provisioning. Um, and the other point is the automatic failover that we can handle manually or automatic with a priority here for our regions. And we'll talk about the consistency levels. I will switch to Andre to talk about the consistency levels here.
Yeah, regarding the consistency levels, Cosmos offer 5 options of consistency level, and these are important when planning for availability. So we have the stronger consistency that is strong, and the least strong consistency, which is eventual. We're going to explain the 3 main ones with some examples. So the strong consistency implies that when I do a write in a region, I have, for instance, in this example, one write region and 3 read regions. When I do a write, it's going to commit on all the regions at the same time. So it's going to wait for the data to replicate to all the other regions. So if I do a write and then I have the response that it's okay, the data is already on all the other regions, and it's that's why it's called strong consistency. I have a guarantee by the platform that every region will be the same at all times. This comes with a price on terms of latency of the writes, so I'll have a little bit of longer write times. The middle consistency that we have is called session consistency. If I have a user that's in a session, it's going to have the same strong consistency that we have, even if I'm writing to a region and reading from other regions. But a separate user using a different session will not read at the same time, but it has a guarantee that the writes will be at the same order. So I'm not going to read at the exact same moment in the session, but I have the consistency that the writes operations are going to happen in the same order. The last and least strong consistency is called eventual consistency, and it's the loosest consistency in that the writes can be read out of order in different regions. So if I do a write in one region and I'm going to read in another region, I can get a different data. For instance, region 4 can have the first data, the first write that I have, but region 2 can read the second one first than the first write. So this will guarantee the largest performance because I don't have to wait anything for my writes to happen. But at the same time, it can lead to some inconsistency if I need consistency between the operations, and it needs to be considered. So that's the main points here regarding the consistency. And Jan's going to talk a little bit about uh, the distribution.
Okay, guys. As Andre mentioned, we have a lot of kind of consistency, right, to work on our Cosmos DB. But in practice, what is impact on our SLAs and etc. Right? So we have some scenarios here that, as you can see, um, we can have regions that has only right um, the region will have only write operations and read operations, and other has only read operations. So depending on our strategy, we will have an SLA different from the other strategies, right? So the main point here is to highlight that depending on our strategy here, we can have data loss and availability loss depending on the strategy that we are using on our region, right? Like this one, we have only one region, one region on on our Cosmos DB, and we are not using the availability zones for this region. So if a zone we have a zone failure here, we will have data loss. Okay, so if we have a zone failure as the previous item, we will have availability loss of our Cosmos DB. If we have regional outage and etc., we will also have data loss and availability loss. So this is why it's very important for us to know uh, which consistency level we have to implement on our Cosmos DB, depending on our strategy with the zones here, the multi-region or single region, or which one we will take here. So Andrea will run further on the SLAs, and we'll bring some scenarios here to sample this.
So when we build an architecture, we need to consider the strategy for Cosmos DB, but also for the service that we're going to use to access it. So if we are using a single region right for Cosmos DB and an app service or any other compute instance, compute service in just one region, and our user is accessing it, we're going to have the SLAs for Cosmos will be 99.99%, and for the app service 99.95%. The compound SLA in this case will be 99.940%, which will be about 25 minutes of outage per month that I can have according to Microsoft SLAs. What happens if I go to a multi-region write? So I have my app service in just one, but the DB is using multi-region write. So my SLA for the Cosmos is greater, but my SLA, my compound SLA is not that greater. We have possibly up to 22 minutes of outage per month still with this region, with this strategy. So in order to do a truly uh, available solution, we're going to have to add a second app service. So we have both our app service and our Cosmos DB on multiple regions, ideally the same, with multi-write on the Cosmos DB. And then in order to have this, I'm going to need also the front door to do the balancing and the distribution. And in this case, we can see the compound SLA of our solution is almost 99.99%, which gives a maximum outage of for a little under 5 minutes of outage that I can expect per month. And it's this interesting that we have this with just two regions. If we add a third region, our SLA is not going to be that great. We're going to have a slight improvement, but not that great, because the SLAs don't change that much for 2 or 3 regions. That's not to say I don't need 3 regions. I might need 3 regions for better um, response time for our users or something like that, but it doesn't impact really the availability of the solution. Okay. So how do we test this? If we have this application, can we simulate an outage on our scenario? And Azure has a new solution that was launched a few months ago. That's Azure Chaos Studio, that allows us to simulate our real workloads in the cloud and to simulate outages, to simulate stuff happening to our environment. For instance, in the case of Cosmos DB, Chaos Studio allows it to fail over one write region to another one. So we can simulate this scenario to see if our application is up to it. So I'm going to show here my screen. This is Chaos Studio here, and it shows how we can create an experiment here. I have created experiments that's going to fail over Cosmos for 5 minutes. I have a Cosmos DB instance running on 2 regions, with West US being the primary and East US being the read region. And I'm going to fail over this for 5 minutes. I have it running here already. You can see it's running. And I have an example here that it's writing in one region and reading in the other. You see here that it happens almost simultaneously here. So it has a very large throughput here, and it's reading on one region and writing on another one. Uh, when I run here, the failover is gonna fail, and since I'm writing to the primary region, it's gonna automatically redirect my writes to the failover region. So we can expect to see if we're gonna have any outages. So I'm gonna run here. It takes a little bit to to process this. So we're gonna go back to Young, and he's gonna show another demo.
Okay, everyone. As Andrea told us, we will have this demo that he will show in a few minutes for us. The data from his app will replicated will be replicated to both regions, and we'll take one region off to stay the read only on the secondary region, right? The other sample will show to us to you guys is that this scenario that we are using an Azure function here. Actually, we will use two Azure functions, right? Uh, Both Azure functions is connecting on our Cosmos DB account that has two two regions here. One region that is in Europe will have the region rights operations, and the second region will have only the read operations, right? So we will show the demo for you. Um, Let me just set up my screen here. So basically, what we have here is uh, two Azure functions, right? That we can specify which is the preferred locations of each one. So I put one here in North Europe and the other one in the East US. Okay, that is our region. One point here that is critical when you use more than one Azure function trigger here with Cosmos DB is that when you do the read, you need to specify the list collection name here. So you need to have a list collection for for each Azure function that we have here. So these functions basically are triggered by Cosmos DB here when we have an operation on the database, right? So I will show to you this running here. Just a second. Okay. So, and we'll do an update on the database here. I'll do the update directly on Cosmos. Okay, applied. And our trigger took the information here, as you can see. Uh, the point here that you can see is that since we have different locations, we have uh, different times here because the data needs to replicate from our central instance to the failover instance and the other regions here on our Cosmos DB. So, but we still on the Cosmos DB guarantee of delivery, right? So we are saving a data on the North Europe region, and this data goes to the United States in less than 2 seconds, right? So it's very fast.
We can see here that Chaos Studio is still running, so it's fading over for the West region here. And we can see that it stopped sending the writes to this region here on the graph. It's only sending the information here to East US. And we can see here, this spike is the writes being redirected here to East US as well. So it will deliver all the traffic to the correct region. And the good thing here is that we don't have to do anything at all on our programming side. And for most cases, we don't even gonna have errors. Our code is gonna stay running, and we don't even it's not gonna even trigger an error. It's gonna still read and insert the data on the secondary region without needing to stop the application. All this is done automatically by Cosmos DB and by uh, the the infrastructure that Microsoft provides. Oh, just because that I had an error, but you see that it will recover. In the case there is an error, it's going to be something. This is probably a timeout, and it's going to happen, and then uh, it's going to recover quickly. So uh, that's that is what we had to share with you today. I would like to thank everyone for watching our presentation. If you have any questions, you'd like to connect with us in LinkedIn, please do so. This is our contacts there. So thank you a lot. Yeah, I want to say goodbye to everyone.
Yeah, thank you very much for your time, everyone, and let's connect offline. Okay, thank you very much.